Alright, so in this video, we're going to be looking at the derivative of functions like e to the x or the natural log of x or something like the log base something of x, something like that. So those are the kinds of functions that we're going to be differentiating in this video. I'm going to be also giving you tips on how to differentiate these functions, and you don't really need to memorize a formula for this because you can always think about how to differentiate one function and then based on that apply it to other functions. So let's start with the basics, which is just the derivative of e to the x. This, you should know, is just equal to e to the x. This does not change. So you look at the e to the x graph, the derivative of that graph is actually going to be the same graph. So at any point, if you want to find the slope of the tangent line, you can just plug it in. You can just look at the value, plug in the x value and that into the e to the x, and that's the slope. So for say you wanted to find the slope of the function e to the x at x equals 1, that's just going to be e. Okay, so that's e to the x. Let's now look at the derivative of natural log of x. The derivative of the natural log function is just 1 over x. So remembering this is really important because this is one kind of format that you need to remember in order to be able to do other more complex problems. So just remember this, and when I talk about other functions, we'll be looking at this format and trying to apply it to get a sort of formula. But you don't have to remember that formula if you remember the natural log of x. Okay, let's look at another one. Let's say that we wanted to differentiate d by dx of natural log of 2x. So this is just going to be equal to 1 over 2x, but remember that's just going to be the outer part, leaving the inner part alone. Multiply this by the derivative of the inside, which is just going to be 2. So this is going to cancel out with this, and this ends up just being 1 over x. And this is the interesting part about the natural log function. Notice that if I have the derivative of a function of natural log of x, this is going to be equal to the derivative of the natural log cx for any real number c. So if you think about this, this should make sense because let's look at another example. So let's see, well, let's not look at an example. Let's actually prove this with what we have here. So this is just going to be 1 over x, and this is just going to be equal to 1 over cx times c, right? This is always going to be the case. Even if c is something like 2/3 or some ratio, it's still going to be true because then the c's will cancel, and this is just going to be equal to 1 over x is equal to 1 over x. So that's just something you can remember if you have something like this. Just remember it's the same as this and just write 1 over x. Or you could just prove it, and that would also be fine. Okay, so this is still relatively easy, but let's look at something a little bit more challenging. This is something that would stump me because I was like, okay, I need to memorize a formula. I don't like memorizing formulas. Let's say that I wanted to find the derivative of log base 2 of x. How would I do this? Now this is why I would get confused because I don't like memorizing formulas, and even if I memorize them, I'd probably forget them in like a week. So how would I differentiate this? So remember, going back to this function here, right? This function here. We know that the derivative of the natural log of x is equal to 1 over x. Now, just remember this general format. If you have the derivative of natural log of x, what is the natural log of x? Well, that's ln base e of x. You need to know that, okay? This is going to be equal to 1 over x, which is what we have here, but we actually have something hidden over here, and we don't write that. But writing it actually is going to help you because this is actually just going to be the natural log of e. Knowing this is super important. although this doesn't matter when we're just looking at natural log of x, this actually is equal to 1, so this just ends up being 1 by x. But this part is important in this problem because we don't have base e. And I should probably write this as log base e, not natural log. This is going to be log e. Okay, so now that we know this kind of trick, just remembering this is really important. So let's try to apply that to this. So let's just do 1, right, over. That's still going to be common. And then we still have this x over here. And then multiply that with ln. Instead of e in this case, we have 2, the natural log of 2. And then technically we would multiply by 1 since it's the derivative of the inside, the chain rule. It does not matter. Again, it's just x, so it does not matter. So this is your answer, okay? This is your answer. Now this is very strong. This is very important to remember because these log-based something functions, they can get kind of challenging sometimes. So let's look at another example. And I'm not going to make this one challenging just so you can solidify it. Let's look at log base 5 of x. This is the same exact thing. It's just going to be 1 over x, write that down, multiplied by the natural log of 5. Okay? And that's your answer right here. Okay, we can box this in. Okay, let's do another example. So let's look at the derivative of log base 4 of 2x. Okay, how do we do this? Well, this is just going to be equal to 1 over, not x, but 2x. We're leaving that alone, multiplied by the natural log of 4. And this is going to be multiplied by the derivative of this function. That's just going to be 2. And notice what happens here. The 2's cancel. And this ends up being 1 over x ln 4. And that's your answer. Now we see another pattern, because if we have the derivative of log base c of x, this is going to be equal to the derivative of log base c of let's look at like another constant. Let's just say, I don't know, let's just do d, right? dx, whatever. Right? This can be anything. Let's make it ax actually. A would be better. Let's make that ax. Okay, ax. This is true because let's prove it, right? Let's just do a quick literal differentiation. So this is just going to be 1 over x, and then of course natural log of c, and this is going to be equal to 1 over ax times the natural log of c multiplied by a, so the derivative of ax, which is just going to be the constant stays the same, and then power rule 1, bring it down, minus 1 is 0, so it's going to be just a times 1 is a. And then of course the a's will cancel, making this just 1 over the natural log of c is equal to 1 over x ln c. So that's just something that we can think about. That was also the case, of course, in the previous example. Let's look at some more examples. I'm just going to do 2 more examples, a little bit more challenging examples here. So let's just look at the derivative of the log base 4 of the natural log of x. Okay, so this seems challenging, right? But it really isn't, because if we think about this, it's just going to be 1 over, and then we have ln x. We'll just leave that just as it is, right? The natural log of x multiplied by the natural log of 4. And then remember, we have to multiply this by the derivative of this function. That's just going to be, well, of course, 1 over x. And then derivative of the x is just 1, doesn't matter, right? At this point. So it's just going to be 1 over the natural log of x times ln 4, right? And this is, you can leave your answer like this. This is completely valid. Okay, what did I do here? Well, basically I use the same thing, right? 1 over log base 4 of ln x is just going to be 1 over, instead of x we have ln x, like we had 4x before, right? We just wrote it like that and then differentiated later. That's exactly how it is. We just do 1 over and then ln x times ln 4, but then we have the inside, we have to, so we left that alone, but then now we have to differentiate it because it's like the chain rule, right? When the chain rule, we leave the outsides and we differentiate the outside, leaving the inside alone, and then differentiate the insides. Same thing here, differentiate the outsides, leaving the inside alone, right? And then we differentiated it, and then we multiplied by the derivative of the outside. Okay, let's do one final example. Let's say we wanted to differentiate the function log base 2 of the natural log of, yeah, let's do that, natural log of the natural log of x squared. Okay, let me keep track of these. Okay, there you go. All right, this is going to be equal to 1, let me do this down here because we need some space. So it's just going to be 1 over, we have the natural log of the natural log of x squared, okay, multiplied by the natural log of 2. Okay, so we did the chain rule stuff, right? Where we just basically did differentiating the outside, leaving the insides alone, multiplying by the derivative of the inside, which is just going to be 1 over, so the natural log of x squared. Again, we differentiated the outside and then left the inside alone, multiplied by the derivative of the inside, which is going to be, again, 1 over x squared, again, leaving the insides alone, multiplied by the derivative of the inside, which is going to be 2x, and then we finally just multiply by 1. That does not matter, but that's there. Okay, so this was kind of long, but you can just finally put this all together, and it's not too difficult. It's just 2x all over. It's a little longer. Well, okay, there we go. Natural log of the natural log of x squared multiplied by the natural log of 2 times the natural log of x squared times x squared. Of course, this x will cancel with this x, and that's just going to become, finally, 2 over the natural log of x squared times the natural log of 2 times the natural log of x squared times x, and then that's it. All right. Hopefully that was a good review of these different kinds of functions, and yeah, this is just kind of a quick review for e to the x, natural log of x, and those kinds of functions. Hope you found this video helpful.